So our universe today, as we understand it based on scientific evidence, is about 13.6 billion years old. And it had a rather violent beginning in the sense that it was very hot and condensed. It was kind of flash of light in a certain way, and it started to expand very quickly. This is a little bit of a puzzle. We assume it had to do it like this because when we look around in space today, it looks pretty much the same in any direction you look. So the only way to understand that it can be like that is that it expanded extremely quickly when it was very young. And when I say very young, it was something like 10 to the minus 32 seconds old by then. So this is a number that is very, very small. It's 1 divided by a number that has 32 zeros and seconds. So it's a very short. So it's not like days. It was just flash, very rapid, violent acceleration, if you like, in its size. And then as it started to expand, then less faster, it started to cool down. And in that process, it became about 400,000 years later visible. You could actually see things. And then another 500 million years later, stars started to form. And indeed, stars are created, they die, and when they die, they, in many cases, explode. And these explosions scatter the contents of these stars into the space, and this becomes new material for new stars. And we have gone through several of these cycles, so the heavier elements are present today because of these cycles that many suns and many galaxies have gone through. And in fact, the stardust, which originates from these stars that have died through violent explosions, have contributed to our existence. We are here today because of stardust, and we are made of stardust. We are the children of the stars. But we are very young. We have only been around as a human species a few million years. The Earth has been around maybe 4 billion years. To put that in perspective, if the age of the universe is 14 or 13 billion years or 13.6, it's a very short time. Even for the Earth, our Earth, and for us, we are toddlers. We are learning to walk. So your second question was that how do the recent findings contribute to our understanding of human consciousness and our perception of reality? So these are very profound questions and require quite a lot of reflection, I think. I'm not sure I can concretely answer how we have directly impacted consciousness, because I don't quite know what consciousness means. There are many definitions for it, and there are philosophers, there are neuroscientists who do look at this question. But here at CERN we would more focus on the question of what is reality, what is our perception of reality. And that is a tough question, because reality, we know, is more than what you see. In fact, our business here at CERN is to understand the world that you normally can't see. and we try to probe as we go inside the atom, far inside the atom, to very, very, very small distances. And through that we try to build up like a Lego model from the smallest Lego pieces, if you like, to use and find a way of understanding these building blocks, the whole universe, upwards. So from these small building blocks we call leptons and quarks, we now know that by combining them we can build matter. We can in fact explain everything around us using very simple models, which is astonishing. So we know that reality is more than what we see. There are recent indications, in particular the discovery of a Higgs-like particle 2 years ago that we all know about. This is a very important step because it explains why we actually, as humans, exist. We exist because of Higgs. Higgs is a mechanism that allows our particles that we consist of to have mass. If the Higgs field didn't exist, we would be light, we would be starlight. We would not be wondering where we are coming from. We certainly would not be toddlers. So we also know that through theories that we have, which we are trying to prove, we know that reality could look a lot more different than we think it looks today. We are confined by our perceptions, which are basically electrical activities inside our brain. We are confined to a three-dimensional physical world. Despite that, we are comfortable with working with theories like Einstein's theories, where we can conceptualize our surroundings using 4 dimensions. Fourth dimension is time. Our latest theories suggest that there could be more dimensions, 5, 6, 7, all the way up to 11. And we are looking for evidence as we speak about new particles that could help us to consolidate this model and to see whether there could be more dimensions. And there are strong hopes, certainly, even today, that we will soon be able to see evidence very soon about these types of additional dimensions. Now, although this would be a great breakthrough in physics, I think it would have even a bigger impact on the perception of people about reality, a perception about the role of an individual in the surrounding cosmos, because just the thought that when you are in a room, there is actually more than what is in the room. That is a profound insight. When you close your eyes, you know that there is something around you which you can't see. So, what does that imply? That's a question that we as a human race will need to figure out. Science is part of it, but it's not only the conceptual part. There is the question of the relationship of us as individuals with our surrounding environment. These are fundamental questions, and science plays a very important part of it, but it goes beyond that. So your third question, why is it important for us to understand the, if you like, the inner workings of of the universe, or the beginning of the universe, is basically, I've answered this. It's important to understand the structure of the universe, to understand how we can govern and how we will govern our destiny. We need a map to guide ourselves. We need a map to understand ourselves. So, what we do here at CERN and elsewhere will hopefully contribute to that. At least I'm very optimistic it will. And I think that the next 10 years is going to change that perception we have, an understanding. Not 100 years, 10 years. I think there is a wonderful revolution in a nice way, not in a violent way, but in a peaceful way, happening in science, because the different fields of science are connecting with each other, and there is a kind of a unification taking place, which is not only driven by us here at CERN, but by many different fields of science, and that is exciting. So I think that we have always, as a human race, been curious. We have been very curious about our origins and where we are going. And religion, for example, which is a very important form of culture, for a very long time was kind of directing and dominating that, until, let's say, the natural sciences started to contribute to this, with Galileo Galilei and even Francis Bacon in England in terms of methodologies and so on. Interestingly, when you use the word metaphysics, the 16th, 17th, 18th century metaphysics is today's science. So when you use the term metaphysics, it's understood, at least in the scientific environment, as a little bit like hogwash or like science fiction. But if you look into the history of metaphysics, it has, I mean, the philosophers' stuff 200 years ago is factual science today. So science, we should not forget that major advancements in, at least in natural sciences, by people like Newton or Einstein and many others, were very often driven by passion to use science to validate some basic insights coming from religion. And this has been today completely lost. It's kind of polarized. It's religion or science, or that science is ridiculing religion. I find this interpretation a bit incorrect. Science gives clear answers when science is used to ask clear questions. That's what is great about science. But it can only answer the type of right question you are posing. And it can't really give answers to the type of questions that it's not designed for. So the discussion we are having here, I think, has to do a lot with, I mean, these questions you are asking are very deep, profound questions. And science certainly can answer a good part of it, but they are always a bit like sub-parts of your questions. And I think in the end that these questions that you are asking, at least today, still have a very strong element of individual self-seeking, meaning that the inner truth is to be found in yourself, in a way. I think you said yesterday that Stanislav Ulam said, we don't need space rockets, we need mirrors. I think that's a very nice way of putting it. Well, we need both.